Bismillahirrahmanirrahim. Hi everyone, Assalamualaikum. Okay, today in this video we're going to continue with the chapter 4, which is analysis of the statically indeterminate trusses. Okay, so in the previous chapter, we already learned how to analyze the statically determinate trusses. So in this video, we're gonna continue with the indeterminate trusses. How to analyze the indeterminate trusses. Okay, so as usual, we have our learning outcome. So at the end of this topic, you guys should able to identify the redundant member or relation. Second is to derive the expression for determining redundant member and relation. The third is able to calculate the redundant forces or reaction using the expression, and fourth is to determine the internal forces of all members. Okay, so apa yang kita boleh nampak persamaannya adalah we still want to find at the end of the problem, we need to identify the internal forces of the members. Okay, so basically dia punya objektif itu adalah sama je. Setiap chapter kita nak cari dia punya internal forces of the member. Alright, so as the introduction, a structure is statically indeterminate when the number of unknown exceed the number of the equilibrium equation in the analysis. Okay, bila mana number of relation ataupun unknown yang tidak diketahui, okay, melebihi number of the equilibrium equation. Okay, so indeterminacy may arise. Okay, indeterminacy ini berwujud as a result of added support or member. Okay, so bila kita ada penambahan support ataupun member, itu boleh menyumbang kepada indeterminate trusses. Okay, so there are some major advantage of the statically determinate. Okay, the first one is the maximum stresses and deflection in determinate trusses are smaller. Okay, so it's better, the stiffness is better than the determinate trusses. Okay, the second one is the statically indeterminate trusses have a tendency to redistribute its load to the redundant support or member in the case of the faulty design or overloading occur. So there ada tendency untuk redistribute the load. Okay, the third one is the truss can support load with the support loading on the thinner member with increased stability. So there kat sini adalah dia punya advantage of using the statically indeterminate trusses. Okay, so tadi saya nak tekankan cakap most of the trusses is the indeterminate trusses. So the analysis of the indeterminate trusses is more involved than the statically determinate. Okay, so maksud nak cakap kalau permasalahan-permasalahan yang kita biasa akan jumpa adalah mostly in the real situation adalah in the indeterminate trusses. Okay, so this is the advantage. So we also have some disadvantage. Okay, so they will become more costly to make the indeterminate trusses since it involve additional of joint and member. Okay, since dia mempunyai redundant member ataupun redundant relation, so dia akan menyebabkan a bit costly. Okay, so the second is the redundant trusses can induce problems such as a differential displacement, which creates stress by the settlement of a support. Alright, so okay, for the indeterminate trusses, so dia akan ada dua. Okay, we call internal and external redundancy. Okay, apa itu internal, apa itu external? Secara generalnya internal tu dalaman, external itu adalah luaran. Okay, so the indeterminacy of the redundancy of the truss may be either external, internal, or both. Okay, so the truss is externally determinate if the number of the reaction component exceed the number of the equilibrium equation. Okay, alright. External tu luaran. Luaran adalah kita nampak dia punya support. So bila mana reaction, number of reaction ini lebih daripada number of the equilibrium, so dia akan menjadi externally indeterminate. Okay, so in this case, the reaction of the components are 4, which is spin ada 2, roller ada 1, roller ini ada 1. So ada 4 reaction, which is exceed the number of the equilibrium equation, which is 3. Therefore, the truss is said to be the externally redundant to 1 degree. Okay. Right. This is how we calculate. So, first of all, kita boleh cari dulu. Secara generalnya, dia ni ada determinate ke indeterminate menggunakan equation m plus r equals to 2j. So, in this figure, in this truss, the m is 21. So, number of reaction is 4 and whereby number of joint is 12. So, dia memang akan dapat indeterminate trusses. Okay, so nak tahu indeterminate trusses, dia adalah external ataupun internal. Kita tengok number of reaction is more than the number of the equilibrium. So, there will become one external redundancy. Okay, so for the internal, so internal adalah dalaman. So, internal adalah dalaman. So, in this case sama juga. Kita akan cari, kita nak tengok dia determinate ke, indeterminate ke, by using this equation. Alright. So, tapi dari segi reaction tak ada masalah. So, we have only 3 unknown reaction and 3 number of equilibrium equation. Okay. So, we can solve. So, in this m plus r is 17, 2j is 16. So, m plus r is greater than 16. So, this will become the internal redundancy. So, since tak ada number of reaction is not exceed the equilibrium equation, so, in this case, yang lebihnya adalah internal redundant. So, internal tu maksudnya member lah. Okay. So, this is the method of the analysis, which is the analysis of the statically indeterminate trusses in this topic is performed by force and displacement method. Okay, the force method is called as the method of consistent deformation and is known as the comparability or flexibility method. So, kita nak analyse ni ada dua bentuk lah. Satu, one is the externally and the second one dia internally. So, we already know how to differentiate between this one. So, externally adalah based on the number of the reaction exceed the number of the equilibrium. So, internally maksudnya dia ada redundant of the member. Okay. So, let's see for the externally indeterminate trusses. Okay, for this example, kita akan inspect them here. Okay, so for this truss, kita akan dapat M dia adalah 5 dan M equal to 5. So, J is equal to 4, whereby the ratio is 2 plus 2. So, it become 4. Okay, so in this case, it shows that R is 4, which is greater than number of 3 equilibrium equation. Alright, so number of degree is 1 degree. Okay, so how we want to solve this externally indeterminate of 1 degree? Okay, so at first, let's say the reaction dx. Okay, so previously kita ada AY, AX, DY, DX. Okay, so 4 ni adalah reaction. So kita nak kena solvekan. So, kita buangkan dx. Okay. So, let's say the reaction dx is removed. Okay. So, replace the pin support at D with the roller support. So, tadi ini adalah dekat location D ni adalah pin support. So, dia dah jadi roller. So, roller hanya ada one reaction. So, dah tak ada dah dx kat sini. Okay. So, the structure will become the determinate and stable. But the consequence ataupun kesan daripada replacekan D ni dengan roller, maksudnya at first dia adalah pin, so ada dua reaction. So tiba-tiba bila digantikan dengan roller akan mengalami deformation. Okay, akan mengalami deformation. The support D will move to a new D prime. And the deformation is delta D O. Okay. Okay. Then we apply a unit load at D prime to the left. Okay, so kita menggantikan lagi, kita kenakan satu unit load dekat D prime. Okay, so bila kita letakkan unit load dekat D prime, this will cause a D prime to move to the left with the distance FDD. Okay, tadi yang first bila kita removekan dia, dia ada bergerak, dia akan bergerak ke D prime dan ada deformation. Okay, bila kita kenakan satu unit load, dia bergerak ke kiri dengan satu lagi distance which is FDD. Okay. Okay, for the D prime to move to the original D required a displacement of FDD times with dx. So we can write down the expression as shown here. Okay. So this is for D to move to original position. Ni adalah equationnya. Okay. So maksudnya jumlah deformation dia campur dengan bergerak ke kiri, FDD dia punya distance with the dx. Okay. Sama dengan kosong. So from the previous unit load method for the truss inspection, kita dah ada ini. So ini adalah equation yang kita dah guna in the previous chapter. So we replace and the displacement. Okay, this is the replacement. Kita boleh tulis dia adalah sebagai rumus ini. Where N is the number of the force due to the end load on the truss and ND ini adalah member force due to the one unit load. So ini adalah common, masih sama lagi. Okay. Maksudnya N ni adalah due to end load, ND ni due to the satu unit load. Kenapa D? Sebab D tu kita punya location lah. So sebenarnya dia adalah represent N kecil sahaja. So therefore this equation will become in this equation. So we gonna use this equation to solve for the externally indeterminate trusses. Okay. So first, this is the step, which is to find the degree of the indeterminacy. So remove the sufficient unknown, which is kita remove sama ada pin kepada roller. Okay. Calculate the force for the indeterminate. So bila kita removekan daripada pin ke roller, dia akan jadi determinate. So kita akan kira dia punya forces of the determinate structures, which is N besar. Betul? Then kita replace satu unit load kat mana location yang kita buang itu. Redundant location, and calculate the internal forces due to the unit load. Okay, then kita solvekan the redundant forces by using this expression. Okay, for example in this case, so kita dah calculate dia punya determinate. Okay, so step 2 kita removekan. Itu bila kita remove, dia jadi determinate. So kita kira macam biasa, like the previous chapter, and the sum. So kita replacekan one unit load dekat mana yang kita location redundant reaction itu. Okay, so kita boleh buat table like this, and we solve by using this expression. Okay, I think we're gonna continue in the next video. Alright, thank you. Assalamualaikum.